Welcome to Skill Session. In this video, we'll discuss the state pattern, one of the behavioral design patterns used in object-oriented programming. The state pattern is a design pattern that allows an object to alter its behavior when its internal state changes. The pattern encapsulates the behavior of an object in different states and provides a way to switch between them. So you can think of this as a as a rag light, at an intersection. So it can only ever be either red, green, or blue. Red, amber, or green. and and that's it, right? So you might have different versions of it with different arrows and different colors, but that all just means that you need to have more states. The things in here cannot operate independently. So let's say we have like a vending machine that dispenses different types of drinks. Depending on the availability of each drink and the amount of money inserted by the user, the vending machine should behave differently. We can use the state pattern to represent the different states of the vending machine, such as no drink available, not enough money, ready to dispense, and dispensing. Each state can have its own set of methods and attributes and can transition to another state based on certain conditions. And another example could be a microwave oven, where you first select the type of oven that you want it to be, then you might choose the wattage, then you'll choose the time, and you'll have to have the door closed before it can actually turn on. If we take a look at this model here, we have the class diagram on the left, where you have the whole state machine on the right part of the left diagram. So you have your state that has operations on it, and then you have different states that implement this interface. And so you use different operations to move around between states that all implement that same state interface. And you can see in the sequence diagram on the right that you go from the context, you hit an operation that will set a new state so that next time you go for an operation, you get a different state. And you'll have this state, or you'll have this context object that keeps track of what exactly is the state object that you want to work with. If we look at this in code, a common way to work with this is with an enum named state. You can have an enum named event, and you could imagine that something like a state machine diagram would make a lot of sense to create before you're doing something like this. In our code down here, which, by the way, I know this kind of violates all the clean code principles we've been talking about, but just to get an overview of it, we have this switch case where it always depends on the state that we're in. So if this machine is off, then we can look for an event that wants to start it. But that's once again going to depend on a state or a set of state, and so on and so forth. So we'll always look for the state and then see what happens in this state if this event happens. And you can probably also see how this could be useful in conjunction with the publish subscribe pattern that we discussed in another video. So one of the things that we might want to do here is also to do something a little bit like what we do in the factory pattern, where we want to return the same object no matter the function call that's made on it, so we can always string things along and keep calling things on that same object over and over again, and have a string of different things happen. The state pattern can help simplify complex conditionals and state-dependent behavior in an object-oriented system by encapsulating the different states and transitions into separate classes. This can lead to a more modular and maintainable code with less duplication and fewer bugs. And generally, whenever you see code that has string comparison, so if you're trying to set a state of something using a string, that's probably an error. If you're trying to have an event or saying that an event it's just the letters in a string, that's probably an error. That's what enums are really good for. So the state pattern can also introduce more classes and complexity into a system and may not be suitable for all types of problems or applications. There's a good reason why the examples that I'm using here is for like a microwave oven or a vending machine, because these are the types of things that we want to use this for, something that actually has a state and where you can do certain things when certain other things are fulfilled. So that's all I wanted to say about the state pattern. Once again, if you have any problems or any questions about it, please ask them in the comment section. I'll try to answer everything as fast as I can. And if you subscribe to the channel, you'll get all of these videos, and I'll see you in the next one.